This tutorial is about writing formulas for polyatomic ions. A polyatomic ion is a molecular ion composed of more than one type of atom joined together by covalent bonds, which we'll talk about in grade 10. The term poly means many. You probably heard that term in math. So if you look at the example here, this is called a phosphate ion. And you can see that there's more than one type of atom represented by this diagram. There's an orange atom in the middle, which is the 1-phosphate. And then there's 1, 2, 3, 4 red atoms representing O4. And this whole group of atoms, okay, works together to form a phosphate ion with a charge of -3. A second example is a carbonate ion. And in this polyatomic ion, it's made up of, you can see, more than one type of atom. There's a black carbon in the middle, one carbon. And then you see in the ion here that there's 3 oxygen. Those are red, 1, 2, 3. And the whole ion has a charge of -2. These atoms are bonded together, they stick together and act as one unit. So let's go over some steps on how to write formulae for polyatomic ions. When writing formulae, the first thing you're going to do is write the symbol of the metal, just like we did before, and the ion charge from the periodic table. Then you're going to write the symbol and charge of the polyatomic ion from the chart on the back of your periodic table that looks like this. It's also on page 93 in your book. Then you're going to balance the positive and negative charges to 0. And the last thing we do is add subscripts. The only difference here is if the polyatomic ion needs a subscript, you're going to need to add a set of brackets around the ion first. So let's do a few examples. The first example here is sodium sulfate, and we want to write the formula. So first we look up the metal on the periodic table. Sodium, right there, only one ion charge, Na+1. Then you notice here it doesn't end in IDE. That's our first clue that it's not a nonmetal, but a polyatomic ion. So we have to go to the chart that's on the back of the periodic table. And we'll look down here and we'll find sulfate right at the bottom, SO4 -2. So we'll remember that, SO4 -2. So then, we've done the first 2 steps. Write the symbol of the metal, write the symbol of the polyatomic ion. Now let's balance them to 0. So do we need more sodiums or more SO4s, which are sulfates, to balance? We need another sodium. Now we have a charge of +2 on this side and -2 on this side. So the final formula is Na. How many of them do we have? 2. A little 2. SO4. So we just write it like this, SO4. And we're done. That's the formula for sodium sulfate. Next, let's try barium hydroxide. So barium on the periodic table, Ba+2. Hydroxide, you'll probably not recognize that. You'll see the IDE and maybe look for it on the periodic table, but after a few minutes of searching, you won't find it. And then you'll think, what about the back? And sure enough, here's hydroxide, OH -1. OH -1. So then we balance the charges to 0. We've got 2 positives, 1 negative. We've done this before. Put another OH there. Now we're going to write the formula. Ba, there's only one Ba, and then 2 hydroxide. So we'll do OH. Now before we put the 2 in, if a polyatomic ion needs a subscript, which it does in this case, you must add brackets first. So I put brackets around the whole OH, and then I do a little 2. And what that means is, you can see here I've got 1 OH, 2 OH. So by putting the brackets there, it shows that we've got 2 hydroxide ions. If you wrote it like this, and just add the 2 at the end, it's wrong. That means you have 1 barium, 1 oxygen, and 2 hydrogen, which is not correct because you have 2 oxygen and 2 hydrogen. So you have to remember to put the brackets in. Next, iron 2 phosphate. So we see there's a Roman numeral there, so let's look at the periodic table for iron. Got 2 charges, +3 and +2. Roman numeral 2 tells us use the +2. So we'll write Fe +2. Then we look at the next ion, phosphate. And you see it doesn't end in IDE. Got to look on the back. Phosphate. It sounds really similar to phosphide, so you have to be really careful. Can't read that. PO4 -3. So let's go back. PO4 -3. So this is going to be a little bit harder to balance. We've got a 2 and a 3. So you've done lots of these. We're going to need 3 irons and 2 phosphates. Total charge is -6 and +6. Now we're going to write the formula. Fe, how many Fe's? 1, 2, 3. How many phosphates do we have? 1, 2. So we're going to write PO4. Now we have to add a subscript. So we're going to put brackets around it and add the 2. And we're done. Iron 2 phosphate. Okay, next is ammonium hydroxide. So let's look for ammonium on the periodic table. It'll look a long time. There is no element called ammonium. And it's the only example that we'll use this year where the polyatomic ion has a positive charge. That one's a little tricky. So the formula for this is NH4 plus hydroxide. Even though it ends in IDE, we know it's not on the periodic table. It's on the back, hydroxide, OH -1. The charges are balanced. Okay, that's easy. NH4 OH. No brackets are needed because we don't need to add any subscripts. So that's a little bit of a tricky one because there's actually 2 polyatomic ions joining together. Last example is calcium hydrogen carbonate. So that looks like it actually has 3 elements in it. It can be a bit confusing at first. Let's start with the metal, calcium. Look on the periodic table, Ca+2. And the reason I picked this one is so that it doesn't stump you later on. Hydrogen carbonate. So you may want to put an H here and then look up carbonate. But you might have noticed there's actually a polyatomic ion with the name hydrogen carbonate. So those second 2 words, hydrogen carbonate, represent the name of that one ion, HCO3 -1. HCO3 -1. So then we've got to balance out the charges. HCO3 -1. We need 2 of these to balance out. So we've got -2 on this side, +2 on this side. Final formula, Ca, we've got one Ca. Remember, don't need to put in the invisible one there. And then we've got two bicarbonate ions. Have to use brackets because we have to add a subscript at the end with the two. Calcium hydrogen carbonate. Okay, I've got a few examples here. Try the following skill testing questions, show them to the teacher, and then pick up an assignment. Good luck.